Hi everyone, thanks to be here for the second talk of the day. At the beginning, I was asked to show you a QR code. If you have any question, please ask them on Slido and I will try my best to answer them at the end. I'm Nicolas Frankel. I've been a long-time software engineer and now I'm also doing developer advocacy. I don't remember how many times I spoke at GeeCON, but I'm very happy to be here again. This talk started by a stupid idea. Like, imagine you are an engineering manager or a team lead or whatever, and you ask your teams to test on the target environment, which is Kubernetes, every time you do a PR. I mean, that doesn't seem to be super complicated, right? Who is doing that at the moment? Couple of hands. Well, I'm not the best engineer ever, but I thought that was pretty simple. It took me actually 85 attempts to manage to get it. So I thought, perhaps there is something that I could help people with, because it doesn't seem to be as simple as I thought. A couple of years ago, I wrote a book about integration testing, so that's why I'm very, very interested in testing. And the idea, one of the ideas in the book that I mentioned is the closer you are to the target environment, the more trust you have in your test. So, because the book is quite old, at the time there wasn't any test containers, so I mentioned that, for example, if you want to do integration testing with a database, well, if you are using the target database, for example, Oracle, it can be a problem with the setup of Oracle, it can be a problem with the license of Oracle. So instead we use an embedded database to have fast tests so that you don't depend on anything. But of course, it's not Oracle. So there is a lower confidence in the test that if you use the target database. In this talk, I will mention a couple of components. Basically, you have an app, you have codes, you have at least an integration test, which is normal. You have a target Kubernetes cluster. And more importantly, you have a continuous integration pipeline. As for the implementation, because I want not only to have theory, but a bit of practice, I want to have a couple of implementation of this. So I have a Java application. I have a workshop where I show a Python application. So the technology underneath is not that important for what I want to show you, but I still need something concrete. I have a Postgres database. I have two endpoints, a get and a post endpoints. And basically my test gets all the entities from the get endpoints, count them, use the post endpoint to create a new entity, get them all again, and I want to check that there is one additional at the end of the test. That's how I test the whole stuff. I will be using Google Cloud Platform, not because it's the best, it's because the one I know the best. And I will also be using GitHub because it's pretty popular, but nothing prevents you from using GitLab or Jenkins or whatever you want, or Bamboo. However, we have one decision to make before, is how do we create the Kubernetes cluster? Because basically we are depending on this cluster, and where we create it is very impactful, actually. So one thing we can do is we create it once upstream, and it's there forever, which is good because when we run the test, it will be ready. But it will be costing us money, right? Or we can create the cluster at the beginning of each workflow. But the problem is it takes time to create a cluster. So on Google, it takes about between 5 and 7 minutes every time. And so if your pipeline is slow, doesn't add that much, you don't care, but then you have another problem, the pipeline is slow. But if your pipeline basically takes 5 minutes, you add another 5 minutes, it doubles the time of your pipeline, which is not great. We want fast feedback. So it's all a decision between three factors: money, speed, and isolation. Because if you have a single cluster and you want to like deploy your stuff in this same cluster, then you might run into isolation issue. Some objects in Kubernetes are not namespace scoped, they are cluster-wide issue. Another factor you might take into account, just the control plane of a GKE cluster is around $80 per month. So depending on your budget, it might be something you might want to consider. The decision I took for this stupid demo is to have an upstream cluster because I want speed, but I also want isolation. So what I will be doing, I will have a big cluster. Well, in my demo, it will be a small cluster, but what you can do is to have a big cluster. And inside this big cluster, every time you actually run a PR, you create a virtual cluster. In this demo, I will be using something called vCluster. As the name implies, it's for virtual cluster, so I can create a virtual cluster inside my big cluster. No GKE detailed setup, because the talk is not about GCP. Not too many apps in 3.6. It can be Python, Java, whatever. And I will be using GitHub Workflow and as many actions as possible because I'm super lazy. So the workflow has several steps. The first, obviously, is to build a container. The second is you need to push the container to a registry. Here, in this case, I will be using the GitHub container registry, again, because I will be using GitHub. I will create the virtual cluster inside my target GKE. I will deploy the container, and I run the test. That looks super easy. Remember, 85 attempts to do something that stupid. First, this is the easiest part. Who isn't familiar with GitHub Actions? A couple of hands. So basically, it's in YAML. Sorry for that. The first thing is you declare the triggers. How do you trigger the workflow, the pipeline? Here, I will be triggering it on every pull request that goes to the master branch. Of course, you adapt it to whatever your branching strategy you have. Something very important at the beginning, I have this workflow dispatch, meaning I can start it manually, because again, probably you will make a lot of mistakes. Second thing, you need to declare your parent image. Here, I'm not making things complicated. I'm using Ubuntu latest. Again, latest is a very bad decision, but it's for a demo. I will be needing to actually read the content of the repository to publish the container, so I need a couple of permissions. And depending how much flexibility or reusability you want to have, you might declare a couple of environment variables. Here, this one is important. Does it work here? No. Yes. How long will you keep the Docker image? Because it's just for a PR. You might not be interested in keeping it for long because storage costs money. But if something goes bad and you want to check the Docker image, you might want to download it. So I keep it at 1 day, but your mileage might vary. And then you do the checkout. Second step, you need to log in into the GitHub Docker registry. That's quite easy. Again, you have a couple of environment variables that you need to pass. So I lost it again. So here is the registry itself. I declared it as a variable. It's not necessary, but I did it for fun. The second one is the GitHub actor, basically the account that starts the workflow. And the last one is the GitHub token, and you don't need to do anything for the last two ones because they are part of the GitHub workflow anyway. So that will allow me to push to GitHub. Now we have an interesting problem. We need to store the image, that's correct, but every run of the workflow will create an image, and an image has a name and a tag. And the tag needs to be somehow unique because we don't want to have one image overriding the other. So what do you think would be a good unique tag for that? Sorry? Timestamp. Timestamp is a very, very sure way to get a unique stuff. That's pretty good. Another option? That's not the option that I chose. PR number, and that's a good idea at the beginning, but then if you need to run the workflow twice for the same PR, you will override each other. So timestamp is more unique. Last commit ID, same as PR number. You can do 2 runs of the PR because something on the other on the GCP side, like failed, was not set up properly, and you will still override the image. So the best idea so far was timestamp. The problem with timestamp is I don't know how to bind it to a workflow. So I will just use the GitHub run ID, which basically is something that is given by GitHub. During each workflow, it assigns you a random ID, and then there is no problem of overriding. Every one of them will be unique, and in the same workflow, I will have different run IDs. So I can have multiple images for the same PR, because there will be different tests. Next step, I will actually create the image tag. That's what I mentioned. I just need, I'm using this metadata action. The action basically creates the label and the tags, and you can add additional labels. They gave a lot of labels by default for you here. I'm not overriding anything because it's a demo. I'm keeping the basic labels, but I'm overriding the tag. And I say, please don't try to be smart, use the GitHub run ID. Note that here in this one, I'm using this ID meta because the outputs of this action are not in the log, are nowhere. I want to reuse the output in the next step. Finally, I can build and push the Docker image. So there is another action for that. I'm using this action. So here I need a Docker file that I assume will be in the same folder, meaning that you can't use Spring Boot build image or whatever. You really need a Docker file if you want to use the action. And as I mentioned, I'm using the output of the previous step here, meta, to fill the tags and the labels. And finally, I push. Whew. That's done. Seems very simple. Next step, we need to authenticate on Google Cloud. And even though I don't want to bore you with the details, it's still a bit involved. So the first concept that you have is a service account. Service account is an ID, but not tied to a physical person. As the name implies, it's tied to a service. Then you have the workload identity provider. I think that they recently renamed it, but very recently. So for the talk, I will use this name. Basically, it manages the identities from a provider. And finally, you have the workload identity provider pool, which binds the configuration of an external identity provider to the provider. And here, this is, from a graphical point of view, the concept. A role has multiple permissions. The service account can have multiple roles. It belongs to a workload identity pool, and then the provider, and then finally GitHub. So basically, GitHub will be sending a request with some kind of data, and for that, it will use an OpenID Connect request. And you need to bind the attributes from the GitHub request to the attributes of what Google is expecting. So it's just a mapping one-to-one. It's quite easy. And I think that 1 year ago, 6 months ago, they required that you set a condition. So it's not only about all those 4 attributes that you can just copy-paste. It's about adding a condition. The condition is a bit more tricky because here, obviously, every time I will be running the workflow, it will work because the actor needs to be myself, or at least my ID on GitHub. Meaning that if I work with you on the same repository and you are the workflow initiator, it will fail, which is not a great idea. So in that case, probably a better way to do that would be that the assertion repository be the repository you work on and which the workflow belongs to. So now we are authenticated on Google Cloud by using this very nice YAML snippet. This is the project number. For fun, Google uses two identifiers, the project ID, which you define and needs to be unique across all projects from everybody, and the project number, which you need to find out by yourself. So you use the project number, you use the workload identity provider name and the workload identity provider pool name that you created. Then this is easy. The service account is just an email address that, again, you can find. So now we are authenticated on GCP, but we will be interacting with an existing cluster. As I mentioned, I want the cluster to be there before so that it's much faster. So I somehow need to have a kubeconfig. There is an action for that. You basically tell which cluster you want to use and its location. And from that point on, you will get a kubeconfig that you can use. At this point, I would advise you to just check if it works, because it's already pretty fragile. If it works, you will get something like this. So you add this step that you will remove later, and you have, do you see it? The contrast is not that great on the screen. But basically, you will see a lot of default pods that GCP created for you. Good. So if it works, good. We can go further. We install virtual cluster to actually let you create a virtual cluster inside the main cluster. That's easy. We also need to have a unique ID for the virtual cluster. Let's reuse the unique ID that we had before, or a timestamp or whatever, but again, better to have the run ID so you can tie it to something that is existing. You check if there is a failure. We create the virtual cluster. An action, there is no action for that, sorry. There is this run ID. And again, here, I give it an ID because at the end, I will need to do some cleanup, and I did a reference to this step. You can ask, I was about to say you can ask question at any time, but I need to switch to Slido, and it will break the presentation. Sorry. GitHub container registry doesn't allow you to download from it in an anonymous fashion anymore, or was it ever? It's not like Docker Hub. Docker Hub you can download anonymously. If you want a higher level, you need to log in, but GitHub doesn't allow it at all. So somehow, you need to authenticate on the GCP side, actually inside the Kubernetes cluster. And remember, we are now inside the Kubernetes cluster. We need to create a secret so we can download from GitHub. So you pass the different information, of course, the registry, then the actor, and the GitHub token. Again, all of them are already provided for you because the registry is one of my environment variable. Question for you. Why do I do this dry run client? So basically, I'm outputting everything in YAML on the console, and then I pipe it to the kubectl apply. Why don't I just create the secret directly? Seems pretty stupid. No idea? It's a trick that if the secret already exists, here it shouldn't, but in case it already exists, it will create an error. It can't override it. By doing this, I can override the secrets if there is such a secret already existing without creating a failure in my GitHub workflow. You can add as many config maps and secrets and whatever that you want. Here, I'm using a config map to store the Postgres user and Postgres password environment variable, which is good enough because, again, it will just be for the running of the workflow, and probably there is nothing too secret in it. You can use secrets in place, but you do all your stuff. Finally, here I'm only using Postgres, so I will be installing what is required for my test to run. Just helm install or whatever operator you choose to use instead. And now I need to deploy the manifest. I need to deploy the manifest from an existing manifest file. And the issue is the manifest, I created it previously, and the tag was static inside. But during the workflow, I actually used a dynamic tag. So how can we actually update the manifest so that it reflects the container that I want to deploy? Two ways. The quick and dirty way, SED, the tool that every sysadmin knows for ages, or the cloud native way, customize. Customize is a bit more involved because first you need to create a customize YAML file to say, I want to replace whatever with the GitHub run ID, and then you apply it with the K option. SED is much faster, but a bit more complicated. So you just replace the whole string by the string that you want to use. And then you apply the manifest with -f. My advice would be to use whatever is comfortable to you, or if you are comfortable with both, for small things like here, use SED, and if you need to change a lot of different things, use customize. Now everything should be set. The only thing that we need is to actually expose the service from outside of GKE so that my GitHub workflow can access it. With cloud providers, you use load balancer. So in order for that, we have created the service of type load balancer, and we just need to get the IP, correct? If you do this, it will fail. Why? Because it takes time for Google to assign you an IP. So we need to get back to our shell scripts skills or to ask ChatGPT. And basically, we create a loop so that we say, OK, are you ready yet? Do I get an IP? Yes. We continue. No. We time out for some time, and then we ask again. Pro tip, just write it down here so you are sure that in the console you can check and there is something running. Now you should be ready, or at least it seems. Basically, we have deployed the container, we have created the virtual cluster, and the pod isn't ready. So basically, when your tests runs, the infrastructure behind might not be ready. We need to somehow wait for it to be ready. Two ways to do that. I approached it in a very naive way. So my first attempt was using a Docker run action, so something that can run a Docker container, and I found a container that actually lets you wait for anything. It's called wait for X. It works in many different environments. I love it. Basically, you tell, OK, wait until this IP that you got, and you must have a health endpoint, obviously. You've got a 200. That's what I first did. And then on Reddit, I saw some people saying, no, you are pretty stupid. kubectl allows you to do that. So you have a kubectl wait for a condition, and you can wait for the same. So depends on what you want to do. Now imagine it works. I will have a demo afterwards to show it to you, or not. You need to do some cleanup, because now you have a virtual cluster. So you want to delete the virtual cluster so that you don't consume too much money. So we delete the virtual cluster, and the problem, if you do this at this time, there is a chance it doesn't work. Any idea why it might not work? Imagine the workflow fails in one of the earlier phases. This step will never be executed because the GitHub workflow stops at the first step failure. So if you repeatedly fail your test, you have created the virtual cluster, but you repeatedly fail your test, you will be left with a lot of virtual clusters still being there because this step is never executed. So you might say, okay, I'm smart. I will actually say, the semantics is pretty stupid. If always, it means in any case, I want this step to be executed regardless of what happens before. Seems pretty good. But it's still not a great idea. Because if you execute this test in any case, and the virtual cluster hasn't been created, it will fail again. So be ready. This is the final syntax. If always, but really if the vCluster step, the one I assigned an ID to before, the conclusion is success, then I delete it. This cleanup phase with these if, always, and whatever, you can reuse it in a lot and lot of different situations. And now, I will do the demo. Oh, I lost my mouse. Where is my mouse? I lost the cursor. Here it is. So as you can see, it worked at some point. And then I did the demo. Sorry, you can't see it, obviously. So I made it work. I had a demo. I checked afterwards. 2 days ago, I changed the parameters on the Google Cloud. And I did the demo, and it worked twice. So now, let's do it. Here is the full thing. There are additional information in this file anyway. For example, what you can do already is you can already in the GitHub workflow declare some sort of service. So here I'm deploying a Postgres. And so of course here I'm using a Java application. So I install a GRE. I'm caching artifacts for the win. What I want is I want to run unit tests. They are not units. They're actually using the database that I just created in the workflow, but it is not the target goal. It's not the GCP. It's not the GKE that I target. I'm using it inside the workflow. So it still gives me confidence that if it runs the unit test, then the problem is on the other side. And if one of my fail is failing because my code is crap, then it's much faster. I don't need to create a virtual cluster and to spend cloud money. This is what I told you. I authenticate on Google Cloud. I set the credentials. I edit the GitHub image. Here I'm using customize. I install the cluster. I create the cluster. I connect to the virtual cluster. And now it should, yes, of course, it failed. of course, for whatever reason. Let's try to see. Minimal cluster. I didn't create the cluster. I'm an idiot. And I set myself a reminder this morning, create the cluster before the demo. So I will do it in front of you. I will copy paste. This is the talk that I'm doing to you, but in written form. And I will just need to find here. So it takes some time. Console. Sorry for that. I'm responsible, fully responsible for that. I need to check this. So I need to gcloud config set project explain demo. Did I do something wrong? Yes, I did. It's not this one, so I need a new one. The project is explain demo. Fortunately, I always use the same parameters. This is explain demo. Here is explain demo. This should be what's working. I had it here. Yes, I want. Okay. And now, what does it do? That's a bit problematic. Sorry for that. Okay. At least you will see that it takes between 5 and 7 minutes. So let's continue. I log into the registry that is extracting the metadata. I push the image. Some improvement compared to what I've shown you. You can do caching. I encourage you to do caching. I set the config map. Here, my application is using Flyway, so I'm using the config map to both set the Flyway parameters and the R2DBC parameters. The secret that I mentioned, I customize the stuff, so I apply the customize. I do the load balancing. I run the integration test, and I delete the vCluster. So notice that here I'm running the integration test from Maven on the GitHub Workflow side to actually do the tests to the deployed application. I can show you, meanwhile, while it deploys the IT test. So I have the integration, the unit test. Basically, the unit test, I'm using the test container initializer to use the database that I'm set, so basically from GitHub. And I'm inserting the product using the repository only, where this is the same test. It does exactly the same stuff, while the IT test uses a URL, which again, I will be setting in the workflow, and I'm using the client. I'm getting the initial count of all the items. I insert a new product, and I check that I actually have an initial count that is a count that is initial count plus 1. I can perhaps check Slido now. What about security? You give GitHub access to K8 control plane and I will create public IP that is accessible from anywhere. Yes, that's true. But remember, this is in the context of a single pull request, and afterwards you can delete it. You can add any additional security consideration that you want. It's up to you. You said that virtual cluster is easy, but how does it work internally? How does cluster within the cluster actually works? So you are using a controller and a Kubernetes controller operator, that will actually check one of the objects called a virtual cluster. When it sees that, it will create a K3s cluster inside the cluster. And then you can use it from here. You will be completely self-contained. When you connect to it, when you have your own kube config, then you will see no other thing in the same host cluster. So every one of them is completely self-contained. You can deploy CRDs with different versions in a virtual cluster that belong to the same host. You won't see anything. You can also have services from the host cluster that you synchronize to the virtual cluster in case you need to deploy a single service on the host cluster and make it accessible to different virtual clusters. See, that's the reason why you don't do that. I have a timer here. Other questions in the meanwhile? That's a very good question. What's the difference between testing on vCluster and testing on separate namespace? The biggest difference in isolation. So namespace is the worst isolation you can have because some objects, as I mentioned, they are not namespace scoped, they are cluster scoped. For example, CRDs. You have different CRDs. You have only one version possible for the whole cluster. So if one of your PR involves upgrading the version of a CRD, you can't do that. You will impact everybody else. On the other side, you have dedicated clusters, physical clusters. And they take time to create, as is obvious. So there are different solutions between namespace and completely different clusters, and vCluster is one of them. You said it's a bad idea to use Ubuntu latest, in which case this is not good, in which case it is okay. So first, using latest means that your image is not stable. You are depending on GitHub to update the image. And if you depend on something that is version dependent, it might break your build for no good reason. Second reason, Ubuntu is a pretty large image. Probably you don't need everything inside of it. So perhaps one of the optimization that you can have is actually to provide your own base image, or at least to have an image with a dedicated tag so you can have stable workflow and use it. Thanks for the questions while this G-Cloud is creating. It would be good if you had another question. It sucks. That's why you put alerts, and you shouldn't remove the alerts. That I've described, that I've described. Compared to what I've shown you, I've slightly changed the order, for example. What you can do also is to have stuff in parallel, because basically you can prepare the cluster on one side and create the image on the other side. Those are completely unrelated concerns. If you parallelize them, it will be much, much faster, of course, and you can also decrease your workflow runtime. Yeah. let's see, I have 10 minutes. I apologize again. I feel very bad, honestly. What can I show you meanwhile? Yeah, improvements, obviously, that's what you ask and I mention. You can have a better base image for better performance and optimization, and use caching as much as possible. Here I try to do a bit of caching, but you can improve the caching a lot in your GitHub workflow. It will definitely improve the performance. If you have a workflow that runs for 10 minutes, then shaving off like 2 or 3 minutes is a good win. It's ridiculous. So I didn't get the. Yesterday it was super fast. It created not yesterday, the day before yesterday. It created the instance in less than 5 minutes. I was super happy. I say, wow, amazing. Yeah, it's Friday. But the good thing is here I have time. So it will tell me exactly how long it took. Any other question? How do you determine how long you should wait in your pipeline? That's a very good question. So here I have 2 different approaches. In my pipeline here, for the IP address, I have 10 attempts for 10 seconds each. So far, it worked in 3 or 4 attempts. Obviously, here the timeout is 100 seconds. For the wait for, I didn't set any timeout because I know that at the end it will work, but of course, the wait for X allows you to give a timeout. And there is no real way or good approach for me to tell you, hey, you should wait for X. It really depends on your own infrastructure. Thanks. I don't know about Anonymous. Few weeks ago, some of our projects stopped building because we use Ubuntu latest. Yeah. That's the problem. You shouldn't use a set image. Most people also will recommend you not to use a tag, but to use the hash itself, the share one. So you can have reproducible builds. What if you want to integrate your app with other service on your Kubernetes, make a call from service? Yeah, so the talk is not about vCluster, but basically you can synchronize secrets from the host to the virtual cluster. As I mentioned, you can also make services visible from the host to your virtual cluster. You can also do the opposite. You make the service from your virtual cluster visible to the host. So if you have dedicated infrastructure, for example, you could have all the observability stack, and you want every one of your PR to create a virtual cluster and the virtual cluster to be observed, then you should probably, you can do that. Are you using Docker layering for faster pushes to image repository? In this case, I don't think I am. Let me check, but you definitely should. That's for sure. This is what I'm using. Basically, I'm using the cache mounts. This is what I'm using for caching. Before this technology, you really had to think what I am copying first. In the orders in which you were copying the files were really, really impacting. For example, if you are using Spring Boot, they have a layer order. First, they will copy the dependency. First, they will copy the dependency, then they will copy the snapshot dependency, then they will copy the resources, then they will copy the source code, because the source code is probably what is changing the most. And if you change the code, then you can reuse all the other layers. With this kind of stuff, it's much less relevant, because actually you keep the dependency that you downloaded somewhere in the cache, and this is actually what takes the most time, is to download those dependency. So if you are using a modern Docker engine, which is my case, I'm using Docker Desktop, then you should have that for free. Would you use test returns caching using checksum, or it would be better to run the test regardless if code and test code not change? That's a very good question. It really depends on your confidence in your infrastructure. Do you have flaky tests, or don't you have flaky tests? If you have flaky tests, then probably you should keep the result of those tests, because if the tests pass in the past and they don't pass anymore, it probably means that your infrastructure is somehow lacking. The best way would be to always run the test and the tests are not flaky. But unfortunately, it depends. Sorry. What is the cost of this approach? And here is my consulting card. It depends. The cost is not important. The thing is, what is the cost and the benefit for your approach? As I mentioned in the introduction, the idea is the closer you are to your target infrastructure, the more confidence you have in your tests. You can decide not to do any integration testing. You can decide to do only unit testing. Those are super fast. We have been doing that for ages. But the problem in that case is how many bugs will appear in production. And that is, I can't answer. It depends on a lot of different factors. So it's not only about the cost, it's about the return over investment. If the cost is X, but in general, you pay 3, 4, 10X because you have bugs that appear in production, probably you would be happy to pay X instead. So be careful about the cost. A lot of our decisions as engineers are either about, oh, let's make it 100% quality, or about the management saying this is too expensive. None of those two extremes are right. You should always try to find the right balance in your context, which provides the most return over investment. In the context might be, are you working, for example, in the microsurgery industry or in Candy Crush? Because then the answer will probably be different. You don't care that much about having a bug that gives diamonds in Candy Crush. You care a lot about having bugs in production if an open heart surgery goes wrong. What are the options for automatically retrigger the pipeline on failure? I'm using my superpower, I don't know. But the problem is, in that case, especially in the first run, you don't want to retry automatically. If you want to retry automatically, it means that you assume that your infrastructure has some issues, and then if you try again, it might work. And then we come back to the issue of flaky test, which is the worst that can happen. Regarding failure, I deleted the vCluster. I showed you how to delete the virtual cluster. I would recommend you in the first few runs not to delete it, especially if it fails. Because then you will be happy to connect inside the virtual cluster through your console or through whatever to check what is really deployed and where the issue was. So do that when everything is running smoothly. Do you always need a public IP? You DNS do for HTTP. It depends on you. But again, if you want to have a DNS, you would need an IP in any way, unless you are using, I don't know, a Cloudflare tunnel or whatever. And if you have a DNS, then we get back to the problem of what unique DNS you would need. So you will need to create, for each run of the GitHub workflow, you would need to create a unique DNS. So to put it somewhere in the DNS registry, that would point to the IP anyway. So I wouldn't recommend that. I'm really sorry, but here you can see it's still working, and I have no clue why. So I think we can call it a day. Sorry for the failing demo. If you have any additional question, you can always ping me on any of those networks. Everything is on GitHub. If you want to do it by yourself, And if you have time, you can check. I created the blog series. There are 3 different parts that describe everything in much, much more detail. Thanks a lot.